Oh, why don't they have the Miss?
Today we are going to start working on something, a little bit of an extension from 8th grade. This is a more algebra material. And this is the example that we're going to work with. So again, a lot of the stuff you see today is going to be similar to stuff you've seen before. There are a couple of extensions and connections we'll make. So here is our situation. You're buying paperback and hardcover books at a book sale. You can spend at the most $20. What are the possible combinations of paperback and hardcover books that you can buy? Looking at the problem, we spoke a bit all week on how on Friday we're going to start learning about inequalities. So you knew that coming in, but what is it about the situation that hints to you this would be an inequality and not an equation?
You use the word at most.
Yeah, this here, at most. What does that mean? At most $20.
The maximum.
The maximum amount is 20. Anything less than or equal to 20. What would this be if this was an equation? What would that say? How would I change this word problem if I knew that I was going to solve an equation, not an inequality? What would this be? If I would spend. Well, right now it's an inequality, but what would the problem look like if it were for an equation? What's the difference between a word problem that's asking us about an equation, or what's the difference between an equation and an inequality?
An equation is like you're trying to solve it so it's like equal, but for that you're trying to solve it so it's true.
Okay, for an equation you're trying to solve so it's equal, an inequality so it's true. Think about the amounts of solutions. This inequality, how much could I spend on books?
20.
I can spend 20. What else can I spend?
19.
18, 75.
Five.
I can spend 0. I can spend nothing. Right?
Miss,
I
can you
can
pick that
spend
up?
any amount.
That ring. It looks so unfair.
So I have options here. There's a range of answers that we're looking for. Okay, so we're gonna find this range of answers, and we're gonna look at what it looks like on a graph. So now, again, still talking about the paperback and hardcover books. If you bought one paperback book, how many hardcover books could you buy? What's the maximum number? How would you figure it out? Figure it out now. If I bought one paperback book and I needed to spend at the most $20, how many hardcover books could I buy?
So you're just buying one paperback?
Only one. If I bought one paperback, how many hardcovers could I buy?
3.
3.
Why 3?
Because if you were to subtract 20 minus 2.50, it gives you 17.50, and then you can only get 3 if you were to multiply 4.50 times 3. You can't go
Good job.
Would I pay exactly 20? No, I would have some change. But the problem is on that 4th book, I would be over $20. So 3 books would be my limit. Okay, so let's write an expression. We're going to actually build an inequality, and we're going to write an expression to represent the total cost of the hardcover books and the total cost of the paperback books. Anyone want to try this inequality, just the expression that represents the cost of the books? Patrick, what do you got?
So x is less than or equal to 20.
So we're talking about specifically hardcover books being H and paperback books being P, because we're trying to figure out how many of each. Here we're looking for the possible combination. So your total amount spent needs to be less than or equal to 20, but we're not trying to find the total amount spent. We're trying to find how many hardcover and how many paperback.
H plus D.
Just the expressions. You don't have to give me the other side of the equation or inequality. But what do we need to factor in here? The price. Because H represents what? The number of hardcover books. And if I'm looking for the cost, what do I have to include? The price. So $4.50 for every hardcover. And then the $2.50 for every paperback. That total amount spent needs to be what?
Less than.
Yeah, if I wanted to finish the inequality, that total amount would need to be less than 20 or equal to, because can I spend $20?
Yeah.
Yeah, I could. If I wanted to use an entire $20 bill, I could. So now this is the inequality that we're gonna work on today. Notice, how is this different from the other inequalities you've worked with before? What about them? There's two variables. Okay, so now we're gonna start to talk about linear inequalities and how we can graph them. Do you have to buy the most books possible? No, how many books could I buy?
Like
At the most.
Or do I have to always buy the maximum amount?
No.
No, what else could I do?
Zero.
I could buy nothing. Yeah, I could buy nothing. There is a limit here though. I can't buy negative books. Right? So when you look at certain inequalities or even equations that are numbers only and no context, it's a little different. When
Gina Milano to the main office, please.
Now, let's say we're trying to find the solutions to a linear inequality. Think back to how we find the solutions to an equation. If I was asking you to tell me if that coordinate was the solution to the inequality, what would you do? Okay, and what are you looking for when you do plug it in?
X is 1.
So let's plug it. We'll try 1 and 2. Okay, I will rewrite this inequality where x is 1 and y is 2. So this becomes 2. What's the symbol? Greater than. So this says, 2 is greater than negative 2. Is that a solution for this inequality?
Yeah.
How do we know? Because negative 2 really is less than 2, and if you wanted to read it the other way, 2 really is greater than negative 2. So this would be a solution. So the difference here between an equation, the values that make an equation true, when we plug them in, both sides of the equation are in fact equal. Here, when we're finding values that work for an inequality, we're actually trying to see what? If the inequality ends up being true. Yeah, does it actually work? Let's try negative 3 and negative 7. Would this coordinate be a solution for this inequality if I plugged it in?
No.
True or no?
No.
No, negative 7 is not greater than negative 6, so this would not be a solution. So that is not a unique topic because we've actually used in equations the value for x and y and we've substituted it in to see if it is a solution. So that part is very similar, but now we're talking about a range here. Okay, we actually just, we can talk about this now. What point would be on this line? If I had y equals x minus 3, give me a coordinate that would fall on that line.
0, -3.
If x is 0, y would be negative 3. Perfect. Does that work for this inequality? Let's take the same values. If x is 0 and y is negative 3. True? Is negative 3 greater than negative 3?
No.
No, so there's something else that we need to start to focus on as well. And so we're going to write what's in red. I know it's a little bit longer, but this is going to help you out. The graph of a linear inequality in 2 variables consists of all of the points in the coordinate plane that represent solutions. And we're looking for solutions. We just talked about the solutions to that one inequality we had up. And we checked what coordinates worked, and we also found a coordinate that didn't. So the graph here is a region called a half plane. And it's created by a boundary line. And you can see the boundary lines on both images below. All of the points on one side of the boundary line work or are solutions for the inequality. All the points on the other side don't work. So if you're looking at the pictures, the images below, that yellow highlighted side, those are all of the solutions to the inequality that's listed here. And let's also, as you're writing, or after you write, shift our attention to the lines themselves, the actual boundary line. This inequality, if you can't see it, is y, this one over here on the right is y is less than or equal to negative 3 halves x plus 1. And that's the graph there. The equation, the inequality, I make that mistake a lot, is the inequality on the left side is the inequality y is greater than 3/2 x minus 1. As you're writing, and as you finish writing especially, take a look at the two graphs and the inequalities that are represented by those graphs, and see if you can notice any differences between the image and the inequality up there. There's a few things that we still need to address. If you look at those two graphs pictured below that paragraph, what do you notice about them?
The one on the right is decreasing and the one on the left is increasing, and the intercept. That's still called a y-intercept, even though it's y. That really, I didn't get that. Because if it's y is on that side of the equation, so how can the plus one be a y-intercept too?
The y-intercept just represents where your line crosses the y-axis. So it's not necessarily, it's the y value when x is 0. Now, okay, so we see on the left-hand side that line is increasing, and on the right image, the line is decreasing. What else is different about the graphs?
There's one that has a dashed line.
Yeah, one of the graphs has a dashed line, the one on the left, and one on the right is a solid line. Now compare the lines to the inequalities that they represent. What do you notice? And the writing kind of explains it, but let's see if we can figure out what would make a dashed line and what would make a solid line.
The solid lines are one, they could be equal to?
Yeah, the difference here is really the inequality symbol. This symbol here, less than or equal to, or this greater than or equal to, would be represented by a solid line. And what that means is any of the values that were on that line are solutions. For example, if x is 0 and y is 1, and I substituted that into this equation, that would become 0 here, and this would become a 1. If I calculate this out, negative 3/2 times 0 is 0. So this inequality would become 1 is less than or equal to 1. Is that true? Is 1 less than or equal to 1? Yes. Which means this coordinate that falls on the line is a solution for that inequality. Every coordinate on this line would be a solution. But if we come over here to the less than or greater than symbol, these symbols would be represented by a dashed line, because if I substituted in 0 and negative 1, this point right here, and I put negative 1, and then I substitute in a 0, so this is 0. Is negative 1 greater than negative 1? No, because that symbol doesn't specifically mention it also being equal, any coordinate on the line is not a solution. So the way we would represent that, yes, it is still our boundary line, but it's not included in the solution set. That would be your dashed line.
Okay.
What if the inequality was an equal sign?
Then it would be an equation. So now remember when you learned how to graph inequalities, and you learned on a number line that this meant that the value was part of the solution, and then this meant that it was like the border, but it didn't count as part of the solution. That's the same idea as the solid line and the dashed line, but now we're talking about a linear inequality. So for you to remember it, if equal, less than or equal to, greater than or equal to, that's that solid line because those points are part of the solution. If it's just less than or greater than, it would be represented by a dashed line because that line itself is not part of the solution, it's just our border.
Okay.
That's one of the biggest differences between an equation and an inequality when we graph it. Okay, so now we're gonna talk about some other differences. Does everyone have whatever they wanted written from this page written down? We're gonna do an example in a few minutes where you'll have to determine if the line would be dashed or solid, so we'll go over that again when we get there. Okay, so now let's actually work on graphing this. If I were to graph, we want to graph the inequality y is greater than x minus 2. Let's think for a second about the boundary line itself. Okay, to create the boundary line, we want to actually graph what that would have been as an equation. The line y equals x minus 2. If we graph this line, what would it look like? The y-intercept would be negative 2. Good, so I'll put that point. So I have this point. And how else would I graph? What else would I do? The slope. What is the slope? 1. So for every 1x, I'm going to advance by 1y. Up 1 and over 1. Now before I create my line, the boundary line, should it be solid or dashed?
Yeah,
Why dashed?
because it's not equal.
Because equal is not part of that inequality symbol. Good. So this would be a dashed line. Am I done? How does this look different than these?
One of the planes is in shadow.
I don't actually have my solution yet. When we're graphing this inequality, the first thing we want to focus on is the boundary line itself. That part is not really new for you because you've graphed lines already. In Unit 2, we focus on graphing lines, which we will be doing in a few minutes again as practice. So that boundary line, the only difference with the boundary line is should it be a solid line or a dashed line. Now, this is not the solution. We actually need to work now on figuring out the solution for our graph. So this is our graph here on the right. We need to find a value that works. Okay? So if we picked a point on the boundary line, would that help us find which side to shade? If I picked a point on the line, like 0, -2, would that help me determine which side of the line to shade as my solution set? No, it wouldn't. Good, I see you shaking your head no. No, it wouldn't because we have to choose a side. Hi.
I think I forgot my tablet in here.
You can check in the back, but I didn't see it. How would we, if I said we needed to figure out the solution for the inequality, which side to shade, how could we do that? How could we see which side is going to make my inequality true? What am I at? What could I do?
What if you like?
Let's see this point here.
Yeah, I was gonna say like.
Let's try that. What happens if we use this point here? If x is 3 and y is -1. Now the image, this shows that it's not part of the solution. Let's see if that works. If x is 3 and y is -1, -1 greater than 1. Is -1 greater than 1? No. So this can't be part of the solution set. Now how can I prove that something on the other side is?
Because.
Could I prove it?
Yeah.
What would you do? If I said, prove to me that the left side of this inequality is the solution for
Then
the
just
inequality.
put +1.
Try. Is that on the other side?
I don't know.
What coordinate do we know for certain that might be easy to calculate with? Is on this side, the side that is shown right now as the solution.
Oh.
What value might be like the easiest one to work with? What coordinate in this solution set that we could just check? Something that's like easy to calculate no matter what the inequality.
0, -1.
0, -1.
No.
3, 2. We could. Okay, let's try that. If x is 3 and y is 2, is 2 greater than 1?
Yeah.
Yeah, okay, good. That works. That works. I'll put that. How about, you said 0, -1. Let's try it. If x is 0 and y is -1, is -1 greater than -2?
Yeah.
Yeah, so that works. What's like the easiest coordinate we see? 0. 0. Yeah, we could try the origin. I'm a big origin fan because what happens when you multiply anything by 0?
It's 0.
Yeah, whether you have a fraction or decimal, anytime you can substitute in the origin, it really helps. Is 0 greater than -2? Yep, so that's the solution. And the reason this is the solution and gets shaded, if I try every single point or coordinate in this area, they're all gonna work. And every little fraction or point in between. These all make the inequality true. And what happens over time as I check all of these values?
It comes blue.
It becomes one huge shaded area. If one coordinate on this side of the inequality works, they all make the inequality true. That's how we choose our side.
How do you find like the boundary is the dotted line and
Yes,
it separates
or solid line.
and it separates the true from the not true?
Yes.
So how do you and then if you okay.
So you'll have options here. When you create that boundary line, you have to determine how do I know which side I should shade. Test a point, any point. If the coordinate you use works and makes the inequality true, that's the side you shade. If the coordinate you put in didn't work, you can just shade the other side.
So
Because
it
if
works
your
either
side
way.
doesn't work, the other side has to
It's
work.
a win-win situation.
Yes, you'll always know.
I don't know rapping, but can we like go over everything like to like sum everything up?
We're actually going to do an entire
Can we
example
go to the
together.
bathroom?
Oh,
Yes, give me just 1 second. We're going to do a whole example and we're going to put everything together.
okay.
Okay. So now I'm going to go here. So let's try this one. Okay, let's start with y is less than or equal to 1/2 x plus 1. If this was our inequality, how would we find the boundary line? What would we do to actually draw the boundary line?
We look at the
You grab
We're going to graph it as if it's the equation y equals 1/2 x plus 1. And if I were to graph that, and I'd like for you to try to right now, how do we graph that?
okay, you're gonna start with the
Go up.
Think back to functions, our second unit. How would we have graphed?
Wait, what's a boundary line?
Well,
What's solid or dash?
Okay, explain how
From the last unit, our last unit, how would we have even begun to graph this line?
Go up one.
What do you mean go up one?
Go up one on the Y.
0, 1.
We our y-intercept. We can use this is in slope intercept form. Please stop. So we can plot our y-intercept, which is positive 1. Good. And then what?
And then go one. Go.
And up 1 over 2.
You start at
Yeah,
like
go.
0, 1.
So yep, we have our y-intercept of 0, 1, and then how do we find another point on our line? We can use the slope, absolutely. We can use the slope. And what does the slope tell us or indicate to us?
Go up one. Go over.
1 on the y-axis.
Good.
And over 2 on the x-axis.
Good. For every increase in x, every one increase in x, what's happening to our y value?
Up 1.
Up by a half. Good. So going every one I advance, I'm going up a half. So going over 2, I went up a whole. But that's really something that we've done in the previous units. I have a couple coordinates here. Instead of just drawing a line and being done, this is an inequality. So we have to talk about the boundary line. Now we know where we're going to put our boundary line, but we have to ask ourselves, is our boundary line going to be solid or dashed? Why solid?
because greater than less than or equal to.
Yes, our boundary line is a dashed line if it's less than or greater than. Less than or equal to, greater than equal to is a solid line. Our inequality here is less than or equal to, so I can just draw the line. Solid line. And what is it about the symbol that makes this a solid line? Like sure, it's less than or equal to, greater than equal to. What does it mean in terms of the solutions? What do we know about the coordinates on the line in terms of the inequality? They are the border. But if I'm using a solid line, what do I know specifically about all of those coordinates? They would make it equal. Yeah, they would be solutions for the inequality. And we can go over an example in a minute. So now I have my boundary line. Am I done? No. What's the last piece of the puzzle for an inequality? I have to find a side to shade. I need to find the solution. I need to find the coordinates that actually make this inequality true. So how do I do that?
You pick one
Pick
-1 1.
What do you mean negative 1?
Uh,
What are you gonna choose right now?
A coordinate.
Choose a coordinate, any coordinate you want. And think as you're going through and you see these inequalities, think about a coordinate that you know you can calculate, that you know you wouldn't make a mistake, that you know you can work with pretty easily. And that might be different for all of you. Okay, so choose whatever coordinate you want. What coordinate do we see that is clearly on one side or another that we could test? Yeah, you could use the origin. That works. I'm an origin girl. I love using the origin because I know how to multiply, whether it's a fraction or decimal or a whole number. I know I can just multiply by 0. So if we substituted in 0 for y and 0 for x, I'm testing out this point here, my origin right there. Let's calculate. There's 0 less than or equal to 1. Is that true? Is 0 actually less than or equal to 1?
No.
Yes.
Yes. If that's a solution and it works, then this is definitely in the solution set, and I could shade everything there. Now, you are done at this point, but because we're just learning it, now let's just test a point on the other side, just to make sure it does work. Okay. What coordinate could we use on the other side?
0, 2.
0, 2. Okay, let's try 0, 2. Let's see if 0 and 2 work. It's on the other side. We don't think it's a solution, but let's just check it. If y is 2 and x is 0, let's see if it works. 2 less than or equal to. Is 2 less than or equal to
No.
1?
No.
No, so this does not work. So that entire side is not in my solution set. Now, do we want to choose a point on the boundary line to see if I know which side to shade? Would it help you to choose a point on the boundary line? No, that's not going to help you find the solution to the inequality. You do have to choose a side to figure out. The dotted line versus the dashed line, the inequality symbol, is going to help you determine if the points on the line are solutions. But then you still would have to figure out which side represents the solution set. So let's summarize biggest differences between graphing a line and graphing an inequality. I'm sorry, these are lines still. The biggest differences between graphing an equation and graphing a linear inequality. What are the biggest differences right now? The line itself, good. If it's a dashed line or a solid line, that boundary line. And what else?
Shade one side.
Yeah, the shading. And really what that comes back to is, think about the original problem we went over. They weren't just spending exactly $20 on books. If they were spending exactly $20 on books, that would be just a line, a regular equation. They're doing at the most $20. They could have spent 20, 19, 18, 17, a whole range of prices that they could have really purchased. That's the inequality, and that's represented by the shading. Okay. Questions? Let me pause this before we start to do our practice.